All right, midterm review, second semester. Circle has a center of this and a radius of that, and the center of that. Okay, that's wrong. So it should be -5, 2, and a radius of 1. What sequence of transformations could be used to show that circle A is similar to B? Translation: 5 units to the right, 5 to the right, 2 down, 2 units up, 5 to the right, 2. That's not going to work. Translation to center: 5 units right and 2 down, 5 right and 2 down. That could work. With a dilation scale factor of 1/3. So 5 to the right and 2 down. Scale factor of 1/3 is going to make it smaller, but it's already small, so that's not going to work. Translation: 5 units to the left and 2 up. 5 to the left, 2 up. Nope. 5 to the left and 2 up. That could work. And a dilation with a center of -5, 2, scale factor 3. So if you move this here and scale factor 3, it's going to make it even bigger. So that's not going to work. So it's got to be D. Let's make sure. 5 to the left, 2 up. Yep. Then a dilation with a center of here. So dilating it at this center, scale factor is 1/3. So which means that the radius, which is 3, becomes 1. So new scale factor is new over old. So the new one is 1 and the old one is 3. Scale factor of a third. Perfect. All right, number 2. Center, which describes how it can be transformed to show that it's similar. So it goes from 5, 5 to 3, 1. So from 5 to 3, this is x. And how do we get from 5 to 3? We subtracted 2. And then from 5 to -1, which is y, how do we get there? Subtracted 6. So x minus 2, y minus 6 cannot be this one. X minus, so that's gone. And that's gone. So it's one of these two. Scale factor is what we're looking at. So remember, scale factor is new over old. So the new one. So circle P is circle O. So O is your new one. So circle O has a radius of 4. And circle P has a radius of 5. So 4/5. Show that circle P is similar to circle O. Circle O is center, circle P, which describes how circle O can be transformed to show that circle P is similar to circle O. So P is the new one. And P is 5. And O is the old one, which is 4. So 5/4. All right, so again, same exact thing. X is changing by subtracting 2. Y is changing by adding 1. So X subtract 2, that could be it. This one's not it. That one's not it. Okay, so you can see this AOD. And then the scale factor is new over old. So the new one, A is mapped to A prime. So A prime would be the new one. A has 1, and then it becomes 2. So new is 2/1, which is equal to 2. So D. All right, number 4. What scale factor could be used to make an image X that's congruent to Y? So scale factor. So scale factor is new over old. So this one right here is 1, 2, 3, 4. This one right here is 1, 2, 3. So it goes X to Y. To prove that, to make the image X that is congruent to Y. So the new one would be Y, which is 3, over the old one, which would be 4. All right, number 5. The central angle of the circle measures 97 degrees and intercepts a minor arc. All right, so central angle, 97 degrees. Intercepts a minor arc. Minor, remember, is less than 180. What is the measure of the major arc? So this one right here, the minor is also going to be 97. The major is going to be all the way around. And we know a circle adds up to what? 360 minus the 97 we have. It's going to be 263. All right, what is WTV? WTV. So what is this one? Okay, so remember, find your V. Always follow your V. And we have this. In, on, or out? On. On is just divide by 2. So 90 divided by 2 will give you that, which will be 45. Number 7. What is KNL? KNL. What's this right here? So here's my V. So that goes with that. But is it on, in, or out? It's in. And what's in? In is marriage, so we're going to add the 2 arcs and divide by 2. And that gives us the inside, right? So this is an arc right here. So that's going to be 60 plus. And then you keep going with that same V, which is 100, divided by 2 is going to give me the inside. So you take a calculator. And that's really 60 plus 100, 160, divided by 2 is 80. All right, number 8. What is the value of x? In, on, or out? This is out. So out is you subtract the 2 arcs, divide by 2. That gives you the out. So here's my V. There's an arc. Follow the V. There's another arc. So what do? Subtract the 2 arcs, it gives me that. So 65 minus 25 divided by 2. So 0, 40 divided by 2 is 20. Solve for x. Well, we know that when it's a semicircle, right, this is what? This is 180, right? And you can see the V is right there with 180, and that's on. So how do I get from here to here? Divide by 2. So this right here is a 90. And so how do I set that up? 2x plus 5 equals 90. Subtract 5. 2x equals 85. Divide by 2. X equals 42.5. Number 10, what is xz? xz. So what is this? 6x plus 10. Okay, so remember, when this is also equal to this, and this is also equal to that. Now, because they both have 2, because they're equal, they both have 2 ticks, this is equal to that. So 6x plus 10 equals 8x minus 5. So what do we got? I'm going to take 6x to the other side, 5 to the other side. That's going to give me 15 equals 2x divided by 2. X equals 7.5. Now, the question was, what is xz? So I'm not just asking for x, but I'm asking for the whole thing. So be careful because you have to plug it in. So that whole thing is 6 times x, which is 7.5, plus 10. Six times 7.5 plus 10, 55. All right, number 11. Quadrilateral is inscribed in a circle. Okay, let's go ahead and make a quadrilateral in a circle. Bam. The ratio of P to R is 2 to 4. So P, Q, R, S. Remember, you go in order clockwise. So the ratio of this to this is 2 to 4. What is the measure of R? So remember, these have to do what? They have to add to 180, right? Let's just work from the answers. If these are the answers for R, so let's try 30. So if R is 30, okay, the ratio of P to R is 2 to 4, which means R is always going to be twice P. So if R is twice P and R is 30, then P has to be 15, because 2 times 15 will be 30. But 15 plus 30, is that going to give me 180? No. So that one's not it. Let's try 60. All right. So remember, R is always twice P because its ratio is 2 to 4. And we can say divide both sides by 2. It's going to give me 1 and 1 to 2. So we can simplify the ratio basically. So P to R is 1 to 2, which means R is twice as big as P. All right. So if R is 60, then P has to be 30 because R has to be twice as big as 30, which is 60. But 30 plus 60 is 90. So 90 is not 180, so that's not it. So we're going to try 120. If R is 120, P has to be 60. Because again, when P is 1, this is twice as big. So when P is 60, this is twice as big, which will be twice 60 is 120. 60 plus 120 is equal to 180, so that one works because the diagonals add up to 180. All right, number 12. Discover a portion of a stone wall to calculate the original diameter, then mark the measured chord KM and its perpendicular bisector, what is the diameter of the original circular wall? What is the diameter of the circular wall? So this is the wall. The question is, what is this?
Oh, I need a second to think.
All right, so remember that I'm going to draw the circle a little bit bigger and label it. I don't like how, so it's saying that this is 4, and we know that this is also 4. And then it's saying that this part right here is 2. And the question is, what is this whole thing? Well, let's remember when it's inside, right? When it's chords, when it's inside, it's part 1 times part 2 equals part 1 times part 2. So part 1, right here, 4 times part 2 of the same thing, because remember it's across, right? Which is 4 equals part 1 of the next one, which is 2, times part 2, which I don't know which it is. So let's label that x. So we have 16 equals 2x. Divide both sides by 2. You're going to get x is equal to 8. So x is equal to 8. Now, you have to read the question, because the question was not what is from here to here. The question was, what is the diameter of the circular wall, meaning the whole thing. What is the diameter? So it's 8 plus 2, so that's going to be 10. So be really careful with what they're actually asking. All right, number 13. What is JBM? JBM, that's this right here. All right, in, on, or out? It's in. Okay, so let's find some V's with numbers. So there's an arc right there. So because it's in, I know it's add in, divide by 2 is in. So there's an arc right there, so let's follow that one. That's going to give me this, right? Which is going to be with this one, which is going to give me that. So what do I do to the arcs? I add them together and divide by 2. So that's going to be 130 plus 70 divided by 2, which is 200 divided by 2 is 100. So this right here is 100. But the question was asking, what is this? So how do I get from here to here? Well, this is a straight line, right? So that means that adds up to what? 180, because it is a straight line. You see the semicircle? So if this is already 100, this has to be 80. All right, number 14. Find the length of PQ to the nearest hundredth. Hundredth means two numbers after the decimal. PQ, PQ. Find the length. Length, 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 length. All right, so length is arc length, right? And there's a formula for that. Okay, so you get your formula sheet and you look for something that says arc length. Arc length, arc length, arc length, arc length. Arc length of a circle. Bam. And you write that down. So you copy it down exactly as you see it. So that's 2 pi r theta over 360. And then fill in the numbers. So arc length is equal to 2 times pi. It doesn't tell me to use pi as 3.14, but I'm assuming it is. But I'm just going to leave it like this for right now. Times r, what's the radius? The radius is from the center to the circle, which is 4, times the angle, the arc, the measure angle, which is 110, all over 360. All right, so all you do is you punch that into the calculator. So 2 times, and now to get pi, see the blue button right here? What you're going to do is hit second, and then the blue button. See, it gives you pi. That way you're not using 3.14 because it didn't tell you 3.14. So just put in pi times 4 times 110 equals, and then divide it all by 360. So 7.6794 blah, blah, blah. So the nearest 100 means two numbers after the decimal. Two numbers after the decimal right here. Then look at this number here. What is this 9 going to do to the 7? Well, if it's 5 and above, what's the saying, y'all? 5 and above? What? 5 and above, something, something. 4 and below, leave it alone. Right, but how do you, what's the saying? What does it say?
I forgot.
Okay, they forgot. Third period forgot.
Five and then let it blow, let it go. Something like that.
4 and below, leave it alone. Okay, anyway, we're just going to round it up. Okay, so 9 makes that go up to 8. So it's 7.68. 7.68, so B. All right, number 15. Which expression below represents the area of the shaded sector? So what is this? This is a sector area. So I'm looking for area of a sector. There's a formula for that. There's a formula for that, and you go find it. So arc length, area, area of a sector, bam. And you copy that down. Hey, shh. Which is pi r squared theta over 360. And then just punch in the numbers. So what we got? Area of a sector is pi. Radius, which is, what's the radius? From the center to the circle is 10 squared, times the angle, which I don't know what it is, so it's m, all over 360. So let's punch in the calculator what we have. So is pi in the answer? You see how pi is in the answers? So I'm not going to punch in pi in the calculator. I'll just do 10 squared. 10 squared is what? 100. So it's going to be 100 pi m over 360. And we can divide these numbers because we can simplify. 100 divided by 360. And you can do math, enter. So 5 over 18. So 5 pi m over 18 is what I'm looking for. 5 pi m over 18 right there. See. All right, number 16. The height of the cylinder is, the height of cylinder A is 26 feet. The height of cylinder B is 14 feet. Find the ratio of the volume of cylinder A to cylinder. So volume of A to volume of B. Well, what's this volume of a cylinder? Again, formula sheets. I'm looking for volume of a cylinder. Bam, right there. Write it down. Pi r squared h. So volume of A will be pi radius of A, h of A, to volume of B, which is pi radius of B, to height of B. And we just plug in the numbers. So this is pi. What's the radius? The radius of A is y. Are y'all serious? The height of A is 26. All right, then we have pi. The radius of B is y, times the height of B, which is 14. All right, and then we just have to simplify this. So we can see that there's pi on both sides. Those are going to go away. So in other words, if I divide both sides by pi, they cross out. I can also divide both sides by what? Y. Divide both sides by y. Remember, as long as you do it to both sides, you're fine. So I have 26 to 14. And then now we just simplify that. Now a ratio can be written as a colon. It can be written in words, 6 to 14. Or it can be written as a fraction, 26 over 14. And then we can just simplify this. What goes in 26 and 14? 2. 2 goes into that 13 times. 2 goes into that 7 times. So I'm looking for 13 over 7. And there's no pi in the answer, so 13 over 7. Okay? You could use a calculator and put 26 divided by, what was it, 14? Gives you that, and then you just hit math, enter, enter. It'll give you back the lowest fraction. All right, according to Cavalier's principle, under what conditions are the volumes of two solids equal? So if you have a cylinder, for example, and you have a slanted cylinder, as long as the cross sections are the same, which means the base is the same and the height is the same, then they have the same volume. Okay, so that's what that means. The base and the height are the same. It doesn't matter what you do to it. You can disform it all you want to. Then the volumes are the same. So let's read through it. When the cross-sectional areas are the same at every level. When the areas of the bases are equal and the heights are equal. When the cross-sectional areas are the same at every level and the heights are equal. That's exactly what I'm looking for. When the cross-sectional areas are the same at every level and the heights are equal. Doesn't matter where you go, the cross-section's always the same. So that's going to be C. Cavalier's principle states that if all parallel planes intersect two three-dimensional figures in cross-section with the same bam, then the figures have equal bam. So it states all parallel planes intersect two three-dimensional figures in cross-section with the same area. So the area of the bases, that's what it is, area. I'm looking for area, so that's either A or D. Once the areas are equal, then the figures have the same volume. The outer radius of the hollow cylinder is 5. So the radius of the hollow is 5. The outer radius of the hollow cylinder is 5. The radius of the inner cylinder that is removed is 3. So the area of the radius is 3. So what I'm going to do is I'm going to draw two things, actually. I'm going to draw the first one and then the second one. So this first one is going to be 5, and this second one is going to be 3. Find the area of the cross-sectional that is parallel to the base of the hollow cylinder. So find the area of the cross-section that is parallel to the base of the hollow cylinder. So of the hollow cylinder. All right, so what's just the area of the cross-section? Well, what's this cross-section? It's a circle. How do you find the area of a circle? I don't know. Let's look at the formula sheet. Area of a circle, pi r squared. So area of a circle is pi r squared. Okay, so area of this one is pi 3 squared, which is 9 pi. Okay, so find the area of the cross-section that is parallel to the base of the hollow cylinder. Okay, so this one is 9 pi. What's the area of this one? Area is pi r squared. So the area is pi. The radius is 5, so 5 squared, which is 25 pi. Okay, now, this is the area of this big one is 25 pi. The area of the small one inside is 9 pi. When you remove the smaller one, because it's hollow, you have to remove the smaller one. So that means you have to subtract them. when you subtract 25 minus 9, 25 pi minus 9 pi, you get 16 pi. So the area of the cross-section that's parallel to the base of just the hollow cylinder of this one, right, is 16 pi. So again, because you're taking it out, you subtract the 2. Now be careful, because the radius of the outer one is 5 and the radius of the inner one is 3. You don't subtract the two numbers. So you find each one individually, and then you're subtracting them. All right, number 20. Find the volume of the cylinder with the base. So volume of a cylinder. So let's draw a cylinder. The area of the base is that. So area is 25 pi. And the height equal to the radius. Give the answer in both terms. Find the volume of the cylinder with the base area is 25 and height is equal to the radius. So this height is r. So find the volume. All right, so volume of any cylinder. Volume of a cylinder. Pi r squared h. Pi r squared h. So let's put in what we know. So volume equals pi r squared, which is really, and what's, okay, area of a circle is pi r squared. So pi r squared right here is the area of the circle. And we know that the area of the circle, they give it to us, which is 25 pi. So this is 25 pi times the height. And what did they just say the height is? They said the height is r. So I guess let's find r. Okay, so let's find r first. So this whole thing is equal to 25 pi. So 25 pi is equal to pi r squared. Divide both sides by pi. This cross out. So you get r squared is equal to 25. So square root both sides. And you get r is equal to 5. So the radius is 5. All right, so now coming back here, you've got the volume, which is pi r squared, so pi and then 5 squared, times the height, which is what they said is also the height equal to the radius. So the height is a radius, which is 5. So the volume is 5 squared times 5 times pi, which is second, and then this right here, equals 392. Do you see that? 392. So D. 392.7. All right, number 21. Write the equation of a circle with the center of that. All right, so remember again, there is a formula. Man, this formula sheet is like your best friend. Circle. Equation of a circle. Equation of a circle. So we'll copy that down. So x minus h squared plus y minus k squared equals r squared. All right, so remember h and k is the center and r is the radius, okay? So we're just going to plug it in. So we're going to write it down exactly how we see it, x minus, and then whatever h is. What's h? H is 7 squared plus, open parenthesis, y minus, and then what's k? K is negative 10 squared equals r. What's r? 2 squared. Okay, simplify this. So x minus 7 squared plus, what does this do? Changes to a positive 4. And then look for that answer. X minus 7 squared plus y minus 10. Okay, so C. All right, 22. A circular parcel of cars first can be modeled with the equation blah, 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 blah. What is the maximum height? Okay, so remember, whenever you have x and y, this is solving the equation of a circle by completing the square. Okay, so let's see if you remember how to do this. So the first things first, they already have the number on the other side for you. They already have the x's grouped and the y's grouped. Oh man, so they really made this question easy for me. So we're gonna rewrite it with the space. So x squared minus 14x, and then I'm gonna leave a space, plus y squared minus 150y equals negative 40. Oh, I forgot to leave a space. Equals. All right, so there's a space there. All right, so then remember, right underneath that, you put parentheses squared plus parentheses squared equals negative 49. All right, so x and y. So how do I get from here to here? Divide by 2, and then do what? Square it. So divide by 2 is negative 7. Square is positive 49. Because I just added 49 to the side, I have to add 49 to the side. Do the same thing with the y's. How do I get from here? Divide by 2, and then square it. All right, so divide by 2 is negative 75, and then square it. Negative 75. Oh, make sure you always put that in parentheses. Negative 75 squared is 5625. So plus 5625. And if you add it to one side, you add it to the other. 625. All right. Now let's combine all of that. So these are going, negative 49 plus 49 goes away. So then it's just 5625. Okay, so then we have x minus 7 squared plus y minus 75 squared equals 5625. Okay, what is the maximum height? So is height x or y? All right, so I'm going to draw this so I can explain it. Let's say you have a circle. Okay, you have a circle. Here's the center of the circle. Maximum height is the radius. All right, forget that picture actually. You have your Ferris wheel. Here's your Ferris wheel. Okay, so it keeps going around. The maximum height, do you agree, would be the diameter of the circle? So if I know the radius, which, remember, the equation of a circle is x minus h squared plus y minus k squared equals r squared. So r squared is this. So find what r is. So if r squared is that, the square root of that, so the square root of 5625, 75. So the radius is 75. Okay, so the radius is 75, but you're talking about the whole height from the ground to the top. So we're going to do 75 times 2 to give us the whole height, which would be 150. So C. All right, which is the equation of a circle that passes through blah, 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 and is centered through this? Okay, so remember, again, start off with the formula x minus h squared plus y minus k squared equals r squared. So I need the center. So centered is h and k. So let's go ahead and write that in. X minus h, which is 5, squared plus y minus k, which is 6, squared equals the radius. Now I need the radius, but I'm not given the radius, so I have to find it. So what can I do is I can find, so if I have hypothetically speaking, without me drawing it, if I have the center, which here is here, 5, 6, and then I have another point somewhere over here, which is 2, 2. And I want to find this distance here because that's the radius. I need to find the distance between these 2 points. So to do that, I need the distance formula. And guess what? You don't even have to remember that distance formula right there. So I'm going to write it out and just plug in the numbers. So the distance formula says square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm just going to label it. So let's do x1, y1, x2, y2. Just plug it in. Distance is the square root of x2, which is 5, minus x1, which is 2, squared, plus y2, which is 6, minus y1, which is 2, squared. And put all that in the calculator. Now, when I put it in the calculator, I'm not going to put square root first. Okay, so I'll just do this without square root. But you put it exactly how you see it. Open parentheses, 5 minus 2, close parentheses, squared, plus, open parentheses, 6 minus 2, close parentheses, squared, equals. So 25. So distance is the square root of 25. The only reason I did that is in case it was a decimal. So square root of 25, the square root of 25 is 5. So the radius is 5. So this radius here is 5. Now, you're supposed to take the radius and then square it. So 5 squared, so 5 and then squared is 25. So x minus 5 squared plus y minus 6 squared equals 25. X minus 5, y minus 6 equals 25. So D. Find the center of the radius. Okay, so this one is again completing the square. First thing you're going to do is take this to the other side. I need some space. I'm going to do it over here. I'm going to do the work for 24 down here. So this is 24. All right, I'm going to write this grouped and separated. So x squared, and then what's the other x that goes with that? 2x. Leave a space, then y squared, and the other y is negative. And then you take 10 to the other side, it's going to become what? Negative 10. So now that I have it set up, I can complete the square. So remember my next step. All right, so here to here, divide by 2, and then what? Square it. So divide by 2 is 1, positive 1. Square that is plus 1. If you do it to one side, do it to the other. Same thing here, divide by 2, and then square it. So divide by 2 is going to be negative 5. Square it is going to be positive 25. If I add it to one side, add it to the other side. And then combine like terms. So 26 minus 10 is 16. And what was my question, actually? If I go too far. Find the center and radius. Okay, so I need to actually find the center and the radius. So remember, it's x minus h squared plus y minus k squared equals r squared. So I got to rewrite that with a minus. So it's got to be x minus minus 1 squared plus y minus 5 squared equals, and square root of 16 is 4. 4 squared. This is your h. This is your k, because it's after. It has to go x minus and then h. Y minus and then k. So negative 1, 5, and the radius is that. So negative 1, 5, and the radius is 4. Negative 1, 5. Negative 1, 5, and radius is 4. So D. All right, number 25. Find the volume of a cone. So look, I'm not even going to read first. I'm going to look for it. Volume of a cone. Write that down. So the volume of a cone is equal to 1/3 pi r squared h. Okay. All right, so the volume of a cone with a base circumference of 19 pi. So circumference is 19 pi. Again, I'm going to look at what circumference is. Man, this formula sheet is like your best friend. Circumference, circumference, circumference. Here we go. That's circumference. So we're going to write that down. Because I want radius in volume, I'm going to use the one that has the radius. Okay, but they're really about the same thing, because 2 times the radius will give you the diameter. But I'll use this one, 2 pi r. So circumference is that, and I know the circumference is 2 pi r. So if I say C is equal to 19 pi, so 19 pi is the circumference equals 2 pi r. And I want to solve for what the radius is. So I'm going to divide both sides by 2 pi. So I'm going to get the radius is equal to the pi's cross out, and then I just have 19 over 2. So 19 divided by 2, that's what, 8.5. 9.5. Hey, checking to see if you're all paying attention. 9.5. So the radius is 9.5 from the circumference. All right. So find the volume of the cone with a circumference of that and a height. So we're finding volume. So that's going to be 1/3 times pi. Does it tell you what pi is? Give your answer both in terms of pi and round to the nearest tenth. Okay, so I'm going to leave pi there. Pi, 1/3 times pi times the radius, which we found is 9.5 squared times the height. And what's the height? Height is 6. Okay, so that's going to be, and then you're just going to put all that in the calculator. So just make sure you use parentheses with the fractions. So 1 divided by 3, that's 1/3, times pi. To find pi, hit second, and then this little arrow, because that's blue pi, times 9.5, and I'm just going to put it in things just to put it in. Because I want to say 9.5 what? Squared. So you see, it's going to square whatever's in the parentheses, which is 9.5. All right, times 6. So 567.057, blah, blah, blah. So I'm looking for 567.057. 567. Oh, man, I didn't finish reading the question. Oh, Lord have mercy. Because it says, and the height 6 centimeters less than twice the radius. 6 centimeters less than twice the radius. Okay, so height is not really 6. The height is 6 centimeters less than twice the radius. Okay, so let's find twice the radius. The radius is 9.5. So 2 times the radius, which is 9.5 times 2, will give me 19. And the height is 6 centimeters less than that. So subtract 6. That's going to give me 13. So the height is 13. Man, they're just complicating this question. All right, then we're going to punch that in the calculator. My bad. I did not finish reading the question. So 1 divided by 3 times pi, so times second and then pi, parentheses 9.5, close parentheses, squared, because that's going to square 9.5, and the height is 13. I'm looking for 1228.624. 1228.624, which is C. So 1228.6. All right. Number 26. What shape is this? A pyramid. What are we finding? Describe the effect. Okay. First of all, hold on. Let's find out what the length, width, and height of the pyramid are multiplied by 1/3. So everything is multiplied by 1/3. What's going to happen to the volume? Well, since I don't want you to just take my word for it right now, let's find the volume as it is. So the volume of what shape is this? This is a pyramid. So shape of a pyramid is 1/3 times the area of the base, because it's capital B, times the height. So 1/3 times the area of the base. And what's the base? What shape is this base? It's a rectangle. All right, so a rectangle of 40 and 30. So what's the area? Length times, or base times height, or length times width, however you're going to say it. So that's going to be 1200. So volume is 1/3 area of the base times height. So the area of the base is 1200 times the height, which is this height of the pyramid, which is 60. So that volume is, and use parentheses for the fractions, 1/3 times 1200 times 60. 24,000. So this volume is 24,000. And the question is asking you, what's going to happen when you multiply everything by 1/3? So if I multiply that by 1/3, that by 1/3, and that by 1/3. So if I do 1 divided by 3 in parentheses times 60, I get 20. 1 divided by 3 times that, I'll get 10, but I'll show you. 1 divided by 3 times 30 and then 1 divided by 3 times 40. Okay, so this one I'm going to leave as 40 over 3 so that we don't have to round. Now find the new volume there. So the volume is 1/3 the area of the base times the height. Now the base has changed to 30 is now 10, and this is now 40 over 3. So multiply those two together. 40 divided by 3 times 10. And math, enter. Will give you the fraction, 400 over 3. So volume is 1/3 the area of the base, which is 400 over 3, times the height. The height is going from 60 to 20. So volume equals, and now we're just punching all that in. So 1/3, 1 divided by 3, parentheses, 400 divided by 3, times 20. And then math, enter. 8,000 divided by 9. So what happened to it? So the volume is multiplied by 1/3. So let's try that. So if we take this volume, the original volume, and we multiply it by 1/3, we'll get 8,000, but that's not quite right. The volume is multiplied by 1/9. Let's try that. So 2,400 times 1 divided by 9. Math, enter. Oh, dang. It still gave me... Why did it still give me a fraction? Okay, well, let's see. Let's turn this one back into a fraction. Let's turn 8,000 divided by 9. Let's see if it's the same one. 8,000 divided by 9. Okay, so no, that's not that one. The volume is multiplied by 1 over 27, so let's try that. The volume was 24,000 multiplied by 1 divided by 27. Oh, look, that's the same one, right? So that's what happens. So the volume is multiplied by that. And the reason being, okay, so if you didn't want to do all these calculations, the reason being is what did we do with every single number? We multiplied it by 1/3, right? So we're changing the volume each time by 1/3. So that's going to be, if you do 1/3 times 1/3 times 1/3, which is 1/3 to the power of, I guess I'll just do it the long way. 1/3 times 1/3 times 1/3. Math, enter. 1 over 27. That's how I changed it, because essentially I'm going to multiply all of them together. So that's the shorter way of thinking about it, but these are proving it with numbers. All right, number 27. Find the volume of the composite figure round to the nearest hundred. So what two shapes do I see? I see this shape, and I see this shape. Okay, so a cylinder and a cone. Let me get all the information. So this one is 3. It has a radius of 3. The whole thing is 6, but this part from here to here is what? 3, right? From here to here is 3. So this part right here is also 3. So that's the height of the cone is 3, and the radius of the cone is 3. All right, so find the area. So area of a cylinder. Area of a cylinder. Not area, sorry, volume. Volume of a cylinder is pi r squared, and of a cone is that. So I'm just going to write those down. So volume of a cylinder is pi r squared h. Of a cone, it's 1/3 pi r squared h. Okay, so just punch in the numbers. So volume equals pi. Radius is 3, so 3 squared times the height, which is 3. Volume equals pi. 3 squared is 9. 9 times 3 is 27. So pi times 27. Volume here is 1/3 times pi times the radius, which is 3 squared times the height, which is 3. Volume is 1/3 pi. 3 squared is 9 times 3 is 27. And then 27 divided by 3 is 9, so the volume is 9 pi. Now, what did they do? They took this and put them together. Put this on top, right? So the total volume will be this plus this. So 27 pi plus 9 pi is 36 pi. And then all you have to do is put that in a calculator. So 36 times and shift second, and then that one. 113.097, 113.0. Huh. Oh, I guess it's what you use as pi. Okay, so you see pi was 3.14. If I use pi as 3.14, I get the exact answer they got. So that's what they must have used. All right, so 113.04. So C. 28. Find the diameter of the sphere with a volume. So a sphere, volume of a sphere. Bam, right there. So volume of a sphere is 4/3 pi r cubed. They say the diameter, find the diameter, and this is the volume. So let's fill in the information we have. Volume is 972 pi equals 4/3 pi r cubed. All right, so let's get rid of, okay. All right, I guess it's several ways I could say this, but let me put it this way. It's 4/3 times pi times r cubed. So to get rid of everything, because it's all multiplication, you just divide. So divide both sides by 4/3 pi, divide by 4/3 pi, and that's going to cross out with that. The pi is going to cross out with that. So you're going to get 972 divided by 4/3. In parentheses, please, which is 729. So you're going to get 729 equals the radius cubed. And what it's saying is some number multiplied by itself 3 times is 729. The cube root, cube, not square, cube root. So r equals, and to find the cube root in the calculator, you put in the number, so in parentheses, 729. And it's raised, if it was like the square root, you'd raise it to the fraction of the number there. So it'd be like 1/2. Because this one is cubed, it'll be 1/3. So raised, which is this arrow, raised to 1/3 in parentheses. So 9. And what I'm saying is basically 9 times 9 times 9 is going to give me 729. So D. Number 29. To the nearest tenth of a cent, how tall is a cylinder with a radius and a volume? Okay, so cylinder. So again, you come here, you look cylinder. Volume is that. Write it down. So this is going to be for 29. Volume is pi r squared h. And then you fill in what they give you. So how tall is a cylinder with a radius of 6.4? So I'm going to have pi 6.4 squared. And I don't know h. And the volume is 119.5, I hope, because I just wrote all over that, so I don't know if that's really what it was there. All right, now just solve that. So we're going to divide both sides, because it's all multiplication, by pi 6.4 squared, pi 6.4 squared. So all that crosses out to leave h. H equals, and then you're going to put that in the calculator. 1119.5 divided by. Okay, you know what? I'm going to do this separately so that you guys don't make a mistake. Let's find out what number this is at the bottom. So it's 6.4 squared, right, times pi, which is second pi. So that's what the bottom is, 128.6, blah, 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 blah. Now I'm going to do the whole thing. So 1119.5 divided by the bottom, and I can type it out, or I can say, you can say second, and then you see where the negative is, where it says answer in blue. You hit that, it will tell you whatever the last answer was, it'll put it in there. So 8.6999. 8.699 to the nearest what? 10th. So nearest 10th is one number, and then what does a 9 do? Make it go up one, so 8.7. All right, number 30, describe the cross-section. All right, so the cross-section is if you cut it, like this sheet of paper is, what is the cross-section going to look like? What is it going to look like? It's going to be a circle. Duh, easiest question ever. All right, number 31. The quadrilaterals of a quadrilateral or blah, blah, blah. What describes it? So PQRS. So I don't know what it is. So PQRS. Remember, it has to go clockwise, right? All right. P is -3, Q is 0, 4, R is 4, 1, and S is 1, -3. Now you can graph this or you could just work it out. So I guess the easiest thing would probably be to graph it. So let me graph it. Lowest X is -3, so 1, 2, 3, and you're going to try and make it as even as possible. All right, so -3, 0, that's P. Q is 0, 4, 0, 1, 2, 3, 4. R is 4, 1, 1, 2, 3, 4, 1. S is 1, -3, 1, 2, 3, 4. Okay, kind of looks like a square, but I don't know. So let's try. All right, let's see if it's a square. Let's check the distances all around. Okay, so distances all around. Distance formula. Write it down. So the distance is x2 minus x1 squared plus y2 minus y1 squared, all square rooted. All right, and what I'm going to do is I'm going to find the distance PQ, P to Q, Q to R, R to S, and S to P. Okay. Okay, so all I'm going to do is actually just put them into the formula. So let's start off by labeling. So PQ, X1, Y1, X2, Y2. And then I'm just going to put it right in the calculator. So square root of, and you know, you could use the slope, but I don't know. I'm just going to go with what I taught you. Open parenthesis, X2, which is 0, minus X1, which is -3. Now, in the calculator, you got to fix that. What are those two negatives going to do? Become a positive. So it's going to be plus 3, close parentheses, squared, plus, open parentheses, y2 is 4, minus y1, which is 0, close parentheses, squared. And you see the squared's over everything, which is 5. So PQ is 5. All right, QR. Since I labeled this X2, Y2, I'm just going to label this X1, Y1, because it doesn't matter what order. So QR, these two. So again, square root, open parenthesis, X2, which is 0, minus X1, which is 4, close parentheses, squared, plus, open parenthesis, Y2, which is 4, minus Y1, which is 1, close parentheses, squared. So far, so good. So we're saying PQ and QR are the same. All right, RS, RS. So since it's X1, Y1, I'm just going to label that X2, Y2. So again, square root of X2, which is 1, minus X1, which is 4, close parentheses. Oh, I forgot to open parentheses. Open parentheses, 1 minus 4, close parentheses, squared, plus y2, which is negative 3, minus y1, which is 1, close parentheses, squared, enter, 5. So far so good. It's looking like it's going to be a square. All right, then SP, or rhombus, actually, a square or rhombus. We have to check. SP. So, oh, look, it's labeled, okay, X2, Y2, all right. So square root of X2, 1 minus negative 3. Again, two negatives are going to make what? A positive, so we'll fix that. Positive 3, close parentheses, squared. Oops, squared. Plus, open parentheses, y2, which is negative 3, minus y1, which is 0, close parentheses, squared, 5. All right, so they're all 5. All right, so that could be either a rhombus or a square. It's not a rectangle. It's definitely a parallelogram, but it's more than a rectangle in a parallelogram. So it's a square or rhombus. To check that, we're either going to check that for it to be a square, because remember, rhombus is a slanted square, right? One of these have to be 90. All right, so I'm going to check QR. Let's check this one. Is QR perpendicular to RS? Is QR perpendicular to RS? All right, so let's go with what's Q? Q is 0, 4. R is 4, 1. And perpendicular means you're going to find the slope, right? So let's find the slope. So change in X. So slope is change in Y over change in X, I'm sorry. Rise over run. So change in Y. So if it goes from 4 to 1, what did I do? Subtract 3. Then it goes from 0 to 4. What did I do? Add 4. Take care of the signs for me. So negative 3 over 4. All right. RS is going to be, R is 4, 1. And S is 1, negative 3. All right. Slope is change in Y over change in X. So change in Y. So it goes from 1 to negative 3. So what does that? That's subtract 4. Over. It goes from 4 to 1, which is subtract 3. Take care of the signs. So it's going to be 4 over 3. All right, so what does perpendicular mean? Perpendicular means that if you take one of the slopes, flip it, and change the sign, that they're going to be the same. So take this, flip it. It's going to be 4 over 3. Change the sign. It's going to be positive 4 over 3. That works. So QR is perpendicular to RS, which means it is a square and not a rhombus. I'm also going to check this one. So flip it. It's going to be 3 over 4. Change the sign. Becomes negative. Negative 3 over 4. So it's perpendicular. Now, there's more than one way to prove a square. We could have done the diagonals are congruent. There are lots of things that we could have done. That's what I chose to go with. All right, number 13, use the slope or distance formula to determine the most precise name for this figure. Okay, so again, I'm just going to sketch it on a graph because I think I like how it looks on a graph. All right, so I'm going to do 32 over here. All right, so I need negative 1 to 4 and negative 4 to 1. All right. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All right, A is negative 4, negative 1, negative 4, negative 1, negative 4. B is 1, negative 1, 1, negative 1. C is 4, 1. 4, 1. And D is 2, negative 2. So that could be, really that could be a whole bunch of stuff. That could be a kite, that could be a rhombus. I don't think it's a square, so I think it's a rhombus or a kite. But all right, so let's take a look. So to prove a kite, remember this is congruent to that, this is congruent to that, and then this is congruent to that, right? So let's start with distance. Let's find the distance around the whole shape and see what we got. So I need the distance from A to B, B to C, C to D. So AB, BC, CD, DA. And all you gotta do is put it in the formula. So I just need to write the coordinates down. So A is -1, -4. B is 1, -1. C is 4, 1. D is 2, -2. All right, and we just label. So A to B. So x1, y1, x2, y2. And again, you just put it in distance form. So distance is square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so all you're going to do is just put it in the calculator. All right, so the square root of open parentheses x2, which is 1, minus x1, which is -1. Again, let's fix the signs. Two negatives are going to give me what? A positive. So plus 1. All right, squared. Oh, that's not squared. Squared plus open parentheses y2, which is -1, minus y1, which is -4. And again, two negatives next to each other are going to make what? A positive 4. Squared. Enter. All right, so 3.605. All right, so let's find BC. So from B to C, if this is already x2, y2, I can label this x1, y1. And we're going to do the same thing. All right, so open parentheses, x2, which is 1, minus x1, which is 4, close parentheses, squared, plus y2, which is -1, minus y1, which is 1, close parentheses, squared. All right, so those are the same. So far this is the same as this. So 3.605. All right, CD, C to D. So this is x1, y1, so this can be x2, y2. Square root of open parentheses, x2, which is 2, minus x1, which is 4, squared, plus y2, which is -2, minus y1, which is 1, squared. Enter. So these are the same. All right, I'm just going to confirm this last one, but it really, so it's not a kite. It's not a trapezoid, so it could be a square or rhombus again. But anyway, let me do DA. So right here, these two. So square root of open parentheses x2. x2 is 2, minus x1 is -1. Two negatives make a positive, squared, plus y2, which is -2, minus y1, which is -4. Again, two negatives make a positive, squared. All right, so all the distances are the same, which means our options could be, it's not a kite, it's not a trapezoid, it's a rhombus or a square. And again, to find a rhombus or a square, we just need to prove one of these is not 90, so we can do AB. AB is perpendicular to BC. So we're checking to see if there's a box right here. So AB. So A and B. So the coordinates for A are -1, -4. Coordinates for B are 1, -1. All right, let's find the perpendicular or parallel is slope. So slope is a change in y over change in x. So y goes from -4 to -1. So what does that do? We're adding 3. And then x goes from -1 to +1. So what do? We added 2. Let's take care of the sign. So that's going to be 3 over 2. All right, now we're going to check B and C. B and C, which is this 2. So B is 1, -1. C is 4, 1. The slope is going to be change in y. So from -1 to +1, we added 2. And then from 1 to 4, we added 3. So this is going to be, fix the signs, 2 over 3. For it to be perpendicular, when you flip it and change the sign, they're equal. So let's take one of them, flip it. That's going to be 2 over 3. Change the sign, -2 over 3. Is that -2 over 3? No. So this is not perpendicular. So if it's not perpendicular, then that means that this is not 90 degrees. And if it's not 90 degrees, then it cannot be a square, because remember, a square has a 90 in all these corners. So it's not a square, so it has to be a rhombus. All right, number 33. Which equations describe parallel lines? Okay, so what do you know about parallel? Parallel means the slope is the same. Same slope. So that's what we need to find out,
If the slopes are the same.
so what we're going to do is we have to put it in y equals mx plus b, where m is the slope, so we can see what the slope is. So take this first equation. 4x plus 3y equals 15, and we need to make it look like this. So that means we need to get x to the other side. It crosses the river, what is it going to become? Negative. Then I need y by itself, so I need to divide everything by 3. So I don't really care about this. All I care about is the slope. So the slope on the first one is that. Now let's take a look at the second one. Now, is that a typo? It must be a typo here. Now I don't know where. I think it's maybe an X here. Okay. That's the slope there. Here's the slope here because it's already y equals mx plus b. And then this one is in the y minus y1 equals mx minus x1. And then that's the slope. So this right here is the slope. So that's the slope, that's the slope. And the slope for the first one is that one. So I'm just going to write it over here. And then on this one, I don't know. I'm thinking there's supposed to be an x here.
I'll do it with an X here and then come back.
If it's not. So I'm going to make it look like that as well. So 3x minus 4y equals -8. Move that 3x to the other side. So -4y equals -3x minus 8. Divide everything by -4. So you're going to get y equals, negative and negative is a positive, 3 over 4x. And I don't care about the rest. So that. So 3 over 4 is my slope here. So which ones are parallel? Which ones have the same slope? 2, 4. 2 and 4. So C. So that's right. So there was missing an X over there. All right, a sandwich shop sells cheese. How can the chef cut a square pyramid shape? So I need a square pyramid shape. So remember, it's a pyramid. A pyramid has one vertex and everything meets that vertex. So it's not that, it's not that, it's one of these. And then the square tells you what the base is. So the base needs to be a square. So both of these are squares. But now, how does he cut a square pyramid shape to make slices that are squares all over? So if he cuts it like this, that's a square. If he cuts it like that, that's a square. All the way down, that's going to give you a square. Whereas if he cuts it like this, through the vertex in the midpoint, that's going to give you triangles. So it's going to be 34. 35, a solid revolution. Okay, so a solid revolution basically is you take the shape and you quickly turn it. Now, I'm going to do it with this, and let's see if you can kind of see. Can you see what shape it would be if I took my pen? Maybe I do it this way. No. Can you see that it will make like a cylinder? So the way I do these kind of problems is draw the exact same thing. That's two-dimensional. Three-dimensional is it's like moving around. So if it's moving around, it's going to become like circles somehow. So that's going to be B, because it's going to be like circles. This will be two-dimensional. That will be three-dimensional. So draw the solid revolution, three-dimensional. All right, number 36. A layered cake is a solid revolution. Draw the two-dimensional shape. So all you have to do is you draw a line in the middle. And what it looks like on the half is what it is before you do all that. So what does that one look like? Doesn't look like that, looks like D. All right, a right triangle with the lengths of 4, 3 has been positioned according plane to coordinate proof. Which set of coordinates could make the proof easier to complete? So a right triangle with legs. So here's my man. Here are my legs. So they're saying this is 3, this is 4. Okay. To write a coordinate proof, which coordinates would make the proof easier? All right, so let's see. 4, 0. Am I not looking for like, the proof would be 3, 0. Because then they say this is in the middle, 0, 0, 3, 0, negative 4, 0. Yeah, that would be the one. So B. Because if this is in the middle, 0, 4, 0, 4, 0, 0, and 3, 0. Yeah, so this is 0, 3 that way, that's going to be 1, 2, 3. 1, 2, 3, 4. So 0, 0, 3, 0, and 0, 4. Because if I did B, negative 4, 0, it would be over here, so that wouldn't be a triangle, so D. That's a weird question. All right, the equations are 4 lines given. Identify which ones are parallel. So parallel means, again, what? Same slope. So all I'm looking for is a slope. So this is already in y equals mx plus b, where m is the slope. So that is the slope. This is the slope. This one is in y minus y1 equals mx minus x1, where m is the slope, so that's the slope. This one isn't in anything. I have to fix this one. So we're going to fix this one. So I'm going to take x to the other side. So it's going to be 1 over 5y equals negative x minus 6. Multiply everything by 5 to get rid of this fraction. So you're going to get y equals negative 5x minus 30. And that's my slope. So the 4 equations are given. Identify which ones are parallel. So which ones have the same slope? So 3 and 2, because this is line 2. 3 and 2 have the same slope. 3 and 2, 3 and 2, 3 and 2, 38. Number 39. Identify lines that are perpendicular. Perpendicular is when the slopes are flipped and change the signs. So that's what I need to find. So let's find each one. So y equals negative 2. So y, negative 2, 1, 2. Y equals always negative 2. Y is always negative 2 no matter what x is. So it's a line looking like this. And what kind of slope is that? Horizontal. So slope is 0. So here, slope is 0. Over here, slope is 1/5. X equals -2. X is -2, 1, 2, -2. X is always -2, -2, -2. X is always -2. Vertical slope undefined. So vertical, vertical. This one's horizontal. And then this one, the slope is -5 because it's in this format again. So identify lines that are perpendicular. So remember, you take the slope, flip it, and change the sign, then they're perpendicular. Whereas if you have a horizontal slope meets with a vertical slope, then it's also perpendicular. So this one and this one are perpendicular. So -2 and y equals -2, x is -2. So this one is perpendicular. And also, this is perpendicular because if I have a 1 underneath, if I take it, flip it, so it's going to be 1/5, change the sign +1/5, I'll get that one. And you do the same thing here. Take that, flip it, so 5/1, 5 divided by 1 is 5, and change the sign will be -5. So these two are also perpendicular. So these two are also perpendicular. So I need the ones that say both of those are perpendicular. Perfect, D. All right, number 40. Find the point P on the directed segment that divides the segment ratio into 1 to 3. All right, so cool thing about this is that there is a formula sheet once again. I gotta find it. See? All right, coordinates of a point which partitions directed segment AB, the ratio of AB from A, x1, y1 to B, x2, y2. So A is the x's, ones, and y1, and B is x2, y2. And then you just punch it into this formula. So what we're going to do is we're going to take this A, B. So A is x1, y1. So A is x1, y1. B is x2, y2. And then you're going to plug it into here. All right, so xy equals the ratio is AB, AB. All right, all you're going to do is put in numbers. So B, which is 3, x1 times x1, which is -18, plus A, which is 1, times x2, which is 0, over B plus A, 3 plus 1, comma, B, which is 3, y1, which is -2, plus A, which is 1, y2, which is 6, over B plus A, And let's take a calculator and put that in there. 3 times -18 plus 1 times 0 is -54, divided by 3 plus 1, which is 4, -13.5. Math, enter. We'll leave it as a fraction, so -27/2. And then 3 times -2 plus 1 times 6 divided by 3 plus 1, which is 0. So -27/2, 0. B. All right. Segment ratio 4 to 1. Man, so this is actually really easy because once you label it, you just put it into the formula. So once again, there's a formula. It's a ratio. So this is going to be A is x1, y1. A is x1, y1. B is x2, y2. The order has to be the same. So if big A was x1, y1, then the first A has to be, this is A, and then B, x2, y2, this is B. First one is 1, second one is B. First one, second one. All right, then all you're going to do is put it into the formula. All right, so you have xy equals b, which is 1, x1, which is -9, plus a, which is 4, x2, which is 11, over b plus a, 4 plus 1, which is 5. Then here you have b, which is 1, y1, which is 5, plus a, which is 4, y2, which is -2, all over b plus a, 4 plus 1, which is 5. And then you just punch in that in the calculator. So 1 times -9 is -9. Plus 4 times 11 is 44 over 5. 1 times 5 is 5. 4 times -2 is -8 over 5. So -9 plus 44 divided by 5, 7. And then 5 minus 8 divided by 5. Math, enter, -3 over 5. So that's going to be B.
All right, number 42.
Find the perimeter. So perimeter, secure the perimeter is the distance around the whole shape. Okay, probably faster to use Pythagorean theorem, but I think I've taught you a lot of distance, so we're just going to do distance. I just need the 3 points. Let's call this, well, let's just say this point here is -1, 1, 2, 3. -1, 3. This point is 1, 2, 1, 2. So 2, 2. This point is 1, 2, 1, 2. So -2, -2. So we need the distance around the whole thing. So distance from here to here. So x1, y1, x2, y2. So remember square root, distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Oh, I mean straight, I'm sorry.
Straight out the formula sheet.
And then all you're doing is putting in the numbers. So let's do that. So it's the square root, open parentheses, x2. What's x2? I just labeled it, -1, minus x1, which is -2. Now we can fix this sign. So negative and negative is going to make what? Positive. Squared. Plus y2. What's y2? 3. Minus y1, which is -2. Again, negative and negative is going to make a positive. And then squared. All right, so that distance is 5.09. And we're going to add that to this distance and to this distance. So let's do this one. So if I've already labeled this x2, y2, I'm going to label this x1, y1, because it doesn't matter. All right, then we're going to do square root of x2, -1, minus x1, 2 squared plus y2 is 3 minus y1, which is 2 squared. Okay, so we're going to add 5, 2, 3, and then finally this last distance. So since I have them labeled like that, I'm just going to change one of these to 2's. So square root of x2, which is 2, minus x1, which is negative 2. Again, change the sign, so that's going to be plus 2 squared plus y2, which is 2, minus y1, which is negative 2. Again, two negatives are going to make a positive, squared. All right, so the perimeter is when you add all these distances up. So that plus 3.16227766 plus 5.099019514. 13.9, which is rounds to what? To the nearest whole unit is
14.
all right, 43. What is the area of the polygon with those vertices? So first I have to know what it is, right? So let's draw it since they give us a grid. -4, -4, 2. It's W. 1, 2, 1, 2. That's X. 1, -2. That's Y. And -4, -2. That's Z. That is. Okay. It's quadrilateral. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right, so it's a rectangle. And how do you find the area of a rectangle? I don't know.
Let's take a look. Area of a rectangle is base
Times height. Area is base times height. So the area is the base, which is 5, times the height, which is 4, which is 20. Oh, and it's unit squared. So it's not this one. Area is always squared because the base is, say, it's in centimeters. And this is in centimeters. Centimeters times centimeters is centimeters squared. All right, find the area and perimeter of polygon with those vertices.
All right.
So we're going to graph that. And a rough sketch is fine. So it goes, 5 is the highest number. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. We're going to make them as even as possible so it can be quite accurate. So -3, 0. That's A. 3, 4. 3, 4. That's B. 5, 1. That's C. -1, -3. That's D. So this looks like a rectangle. All right, that looks like a rectangle. Again, you could use Pythagorean theorem, but because I've taught you so much distance, I'm going to stick with distance. To find the area, it's a base times a height. To find the perimeter, it's a distance all around added. So either way, I need the distance all around. But because I know it's a rectangle, I know this is this and this is this. So I only need to find this one and this one. So find BC, so this BC, so B was 3, 4, C is 5, 1, and then I need to find CD. D is -1, -3. So again, the distance formula. Square root of x2 minus x1 squared plus square root of y2 minus y1 squared. And all you're doing is putting it in the formula. So we're going to label x1, y1, x2, y1. X2, y2, my bad. All right, we're going to put that in this formula. So square root, open parenthesis, x2. x2 is 5 minus x1 is 3, close parenthesis, squared. plus y2 minus y1 squared. y2, 1 minus y1, which is 4 squared. All right, so 3.6. Now find this distances. Since I've labeled this x2 and y2, I'm going to label this one x1 and y1. All right, so again, square root of x2. Oh man, and they leave it in exact form. All right, since I already started this, I'm going to finish it this way, and then I'm going to show you how to do it exact. All right, x2, 5 minus, wait, where am I? I'm on these two. 5 minus negative 1, so 5 minus negative 1. Two negatives make a positive, squared, plus, and then y2 minus y1, 1 minus negative 3. Two negatives make a positive, squared. All right, so that's 7.22. Okay, so to find the area, we're going to multiply these two numbers. So times 3.60, 1, 2, 3, 1, 2. So 26. So it's either A or C. All right, to find the perimeter, you add all of them. Okay, so we're going to have 3.60555125 plus 7.2. So that plus this 7.211102551 plus this, which is 3.6, 1, 2, 3, plus this, which is 7.2, which is 21.63. Okay, so now I'm going to go off the answers. So these are my two options right here. I'm going to just turn that into a decimal. 6 times radical 13. There, so that's the answer, D. If I turn this one into a decimal, see, it's 14.4. All right, so the key thing really is when I was putting it in here, I shouldn't, since the answers were exact, I should have not put the square root until the end, but since it's multiple choice, I can. All right, number 45. A lunchbox contains half a cylinder. Half a cylinder placed on top of a rectangular prism. What's the volume of the lunchbox? All right, so let's cylinder. I need a cylinder first. And to find the area, I'm only going to take half of it. That's going to be what I'm doing. So I'm going to find this volume, take half, and then, so whatever the volume is, times it by a half will give me that. Then when I find that, I'm going to find a rectangular prism. I'm going to add those two together to find the total. So I need a radius. Oh, that's what I'm given. 14. (28, 17, 14). And here, okay, so this is 14, so this is 14. So the diameter of the circle is 14, so the radius is going to be 7. So 7, and this height, because it's, I just fall it down, it's right here. This is what, 28.
Okay, I should have actually just drawn it sideways, but
It'll do. All right, volume of a cylinder. Volume of a cylinder. Write it down. So volume of a cylinder is pi r squared h. So let's find that. Pi, the radius, which is 7, squared times the height, which is 28. Volume equals, and I'm just going to leave pi in the answer until the end.
so I don't have like decimals.
7 squared times 28. 1372. 1372 pi. So that's the volume of this one. Multiply it by a half, because we're only looking for half of it. So divided by 2. 686 pi. And then we're going to add this to whatever volume this is. What is this? A rectangular prism. Prism. So actually, you know, they don't give you prism here, but prism is the same thing as a cylinder, only the area, this is the area of the base times the height. Okay? It's just that in a cylinder, the base is a circle, so the area of a circle is that. So the prism is area of the base times height. So area of this base, and what shape is that? A rectangle, right? So find the area of a rectangle is base times height. So 14 times 17. So the area is 238 times the height times 28. 6664. So plus 6664 equals. All right, now I'm going to go ahead and put the pi back in. Okay, so 686 times, since they don't tell me pi, I'm going to use the exact pi. Remember, it's second and then the arrow. Plus 6664. To the nearest, I guess, whole number, 8819. 8819. 8819. So C. All right, number 46. Rectangular floor. 2 rectangular sides. And 2 triangular sides. Oh, well, that can't be that. Rectangular floor. 2 rectangular sides and 2 triangular sides. There it is. Okay. All right, so rectangular floor. Two triangular. Two triangular sides. All right, so what's the question? What is this? It's not a pyramid because they don't all join at one place, right? So it's not a pyramid. So it's definitely a prism. The question is, what are the bases? So remember, a prism, the bases have to be parallel to each other. If I take the rectangle as the base, it's not parallel to this other side. So it's not that one. And this rectangle has nothing parallel here. So it has to be these triangles, because you can see these triangles are like on the sides of each other. So it's a triangular prism. Number 47, the top of a tall building has 4 triangular faces that slope towards a single point. Top of it has 4 triangular faces that slope towards a point. So if it's all going to a point, it's a pyramid. So it's one of this. The top of a tall building has 4 triangular faces. So 4 faces, which means the base has to be 4 sides. 4 triangular. So this one, the back, and the side. So the base has to be 4-sided. So it cannot be a triangular pyramid. It's got to be a square pyramid. Which 3-dimensional figure could best model a log cut from a tree trunk? I think a log looks like this, right? So what does that look like? A cylinder.
All right, 49.
The borders of Utah, blah, blah, blah. United States, blah, 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 blah. Based on this information, the population density in Utah around your ends. Okay, sorry, maybe I have to read it. The borders of Utah are approximately lengths from the map. The United States Department says Utah will have a population of blah, 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 Based on this information, find the population density. Also, you have to know what the formula is, and I don't think that they give you that formula in here. That's interesting. They don't give it to you, but okay, so its population density is the number of people over the area. So the number of people is that 2990094 over the area. So basically I need to find the area of this. So let's do, you have to break it up into shapes. This whole thing is 345. That means from here to here is this 345, and that little thing is going to make 345. So 345 minus the missing piece, the 64. 345 minus 64 equals 281. So this whole thing is 281. And if I find the area of that, it would be 281 times this, which is the same as this. And I think that says 266. So 281 times 266. So that area there is 74746. And then all I'm left with is this one at the top, which is 64 times the 158. One zero one one two. So add those two up. And you get 84858. So 84858. And then you just put in that in the calculator. So 2990094 divided by 8. 35.23. You can't have 35.2 people, so you can't, so it's 35. All right, so I don't know about you having to remember this, but if you do need it, it is to find the area, to find the population density is the number of people over the area of the place you're looking at for. All right, number 50. The elevator building requires 2.2 square feet per person. The depth of the elevator box is 7. How wide must the elevator be to accommodate 15 people? So it requires this per person, and they're 15. So how many square feet must it be? 15 times 2.2. So it has to be 33 square feet. That means the area of it must be 33 square feet. So this is 7, and this has to be 33 square feet. The question is, how wide does it have to be? Is it a square? Elevator box. I'm going to assume that it's a square. So that means the square root of 33. All right, so it has to be 33 square feet. So the area of the bottom has to be 33. And then the depth, okay, so this is the height. Clearly that's height. It's width and depth, right? So the depth is 7. What's this? Well, what's the area of a square? Base times height. So this times this has to give me that. So to find the question mark, I just divide by 7. Therefore, 33 divided by 7.
It's 4.7.
4.7 D. All right, the area in Alabama, oh my God. How much does it compare to national average? Okay, the area in Alabama is that, population is that. The area of Missouri is that, population is that. The average state density is that. Okay, so we just have to find the population densities. Remember, density is the number of people over the area. So in Alabama, it's gonna be the population, which is 4779736 over the area 51718. In Missouri, it's gonna be population is 5988927 over 69709. So we're going to punch those numbers in the calculator. 4779736 divided by 51718. So that's the density for Alabama, and then for Missouri, it's... You know, Missouri, my language means I'm good. That's so funny. 69709. All right, so those are the population densities, and it says the average state population density is 87.4. How does this compare? So in Alabama, it's higher, and in Missouri, it's lower. So what am I looking for? Population is, in Alabama, is less. No, it's not. So it's not A. Population density in both states are less. No. The population density in Alabama is greater. Yes. So I needed, that's bigger than, yep. And the density in Missouri is less. Yes, so C. 51 would be both of them are greater, which is no. All right, 52, final question. You made it to the end. All right, a homeowner wants to make a new deck for his backyard. Yes, I'm talking to myself. Redwood costs 5 per square foot. The units on the graph are in feet. How much will it cost to create the deck shown? All right, so... All right, we can break this up into different shapes. So I'm gonna do this. And I mean, I hope that you guys, I don't know. Anyway, let me not make any assumptions. Let's see what's on the formula sheet. I don't know if area of the trapezoid is given, and I hope it's given. All right, so it looks like I have a parallelogram, a rectangle, and a trapezoid. But if you don't have a trapezoid, I can break it up further. Let's see what we got. So area. We have a rectangle. Man, you don't even have a parallelogram. Okay, I'm just going to teach it to you anyway. All right. Area of a parallelogram is the same as a rectangle. It's base times the vertical height. So the base of it, which is 1, 2, 3, 4, 5. All right, 5 times the height, not the slant height, but the actual height. So the height would be like that. 1, 2, 3. So that would be the area of this shape. So this will be 15. 5 times 3 is 15. The area of a rectangle is base times height. So the base is 5 and the height is 1. So 5 times 1 is 5. And then the area of a trapezoid. Okay, so you could break this up into like... You know what? Since there's no trapezoid in your formula sheet, I'll break this up into triangles. So here's another rectangle right here. The base is 5 and the height is 2. So that's going to give me 10. Then I have these 2 triangles on the side, right? And the area of a triangle is a half base times height. So a half times the base, which is 1, times the height, which is 2. So that's going to give me 1. So that one's 1. And it's the same triangle, so that's 1. So the total area is 15, 20, 30, 1, 2. So the area is 32 square inch, what are we doing? Square feet. Okay. 32 square feet. And the question was, Red will reduce the cost to 15 per square foot. So it's $5 for every square foot. So we have 32 feet that we're going to need to cover. So it's going to be 32 times 5, which is $160. That's how much it's going to cost. $160.